Hello everyone, I am Zafran from CS department. I am going to explain the experiment on multi-layer perceptron on any non-linearly separable data in neural networks. The agenda of the video is introduction, objective of the experiment, program implementation, execution and result of the experiment, and applications of MLP, and then the summary. Introduction. Non-linearly separable data poses a significant challenge in machine learning, where traditional linear models fail to accurately classify or predict outcomes. To address this, multi-layer perceptrons have emerged as a powerful tool, capable of learning complex patterns and relationships. This implementation demonstrates the effectiveness of MLPs in handling non-linearly separable data, exploring the impact of architecture design, activation functions, and training parameters on model performance. Objective of the experiment: to demonstrate the effectiveness of MLP in classifying non-linearly separable data, to understand the impact of hidden layers and activation functions on MLP performance, to visualize the decision boundary learned by the MLP. And let's see the program explanation. Let's break down the code step by step. This code implements the XOR inputs using NumPy and Matplotlib. The firstly, import libraries. NumPy is for numerical operations and array handling. Pandas are not imported but used in this code. Imported but not used in this code, typically for data manipulation. IO, which stands for input or output, imported but not used in this code, usually for input output operations. Matplotlib is for plotting the loss graph, which we implement in this program. And the second step is initialize data and parameters. X is input data representing XOR, Y is output labels corresponding to XOR, N underscore X, N underscore Y, and N underscore H stands for number of inputs, number of output, and that is number of hidden neurons respectively. M is for number of examples in the data sets. IR is for learning rate for gradient descent. W1 and W2 randomly initialized weights for the neural networks. And the third step is sigmoid activation function, which defines the activation function that maps input values between 0 and 1. Fourthly, forward propagation, which computes the forward pass, returning pre-activation and activation values for both S, which is implemented in this forward propagation code. And fifthly, backward propagation, which computes gradients for the weights, which was initialized in the above code, weights based on the errors, enabling weight updates. And sixthly, training loop. In the loop, it performs forward propagation, computes the loss, back propagates the error, and updates the weights. Seventhly, plotting loss. Plots the loss over the training iterations to visualize convergence. Eighthly, prediction function, which is used the trained weights to predict the output for new input data. And ninthly, testing model. Test the trained model on all possible inputs of XOR, which we used over here. And then this is the output of the program, which we seen before. When giving the inputs, we get the XOR outputs, which is 1 0 1 0. For 1 0 input, we get 1 output, and 1 1 input we got 0 output, and for 0 1 input we got 1 output, and 0 0 input we got 0 output. We already knew that for different input binary options we get 1 as outputs. We can clearly see this, and this is the graph of the program, and then the result. After training the network for 10,000 iterations, the model can accurately predict the output for the XOR problem. For input of 1 0, the predicted output is 1, and 1 1 input predicted output is 0, and for 0 1 input the predicted output is 1, and 0 0 input predicted output is 0. And then the applications of MLP. Image recognition. MLPs are widely used in computer vision tasks such as facial recognition and object detection. By learning complex features from image data, there are so many applications for MLP. We have listed some here, and if you want to know some more, you can browse it out and learn. Natural language processing. MLPs can be employed for sentiment analysis, language translation, and text classification by capturing intricate patterns in textual data. Financial predictions. MLPs are utilized in forecasting stock prices, credit scoring, and risk assessment by analyzing historical financial data and identifying nonlinear relationships. And conclusion. In summary, this neural network learns to solve the XOR problem by adjusting its weights through forward propagation and backward propagation we used in this program. After training, the network can accurately predict binary outputs, which was XOR. We got as 1 0 and 1 0, demonstrating how neural networks can learn non-linear patterns. Thank you.